We had a lively discussion as well. I was joined by Professor James Njuguna from Robert Gordon University, who specialises in natural fibres and biodegradable and bioresins. And we had also Darshil Shah from the University of Cambridge, who was looking at developing biomaterials, engineered wood, bamboo and natural fibre composites. He's big on sustainable composites. We had Dipa Roy from School of Engineering at University of Edinburgh, who's also an expert in bio-based resins and recycled resin composite materials. We had Vicky Summers, Principal Research Engineer from the National Composites Centre here in Bristol, and she's got a particular focus on sustainability, giving us a really key industrial angle on all of this. And Eleni Toumpanaki, she's from Bristol University in the Civil Engineering Department, and she's got a lot of expertise, particularly around timber and use of timber in construction, but also other sustainable composite materials. A question from our audience, which was, how do you define sustainable composites? And Vicky, do you want to add anything to that?
Everyone, thanks, Steve. For us at the National Composites Centre, we've taken the lead from the definition of sustainable development that you mentioned in your talk earlier. So it's about composites meeting the needs of the present whilst not compromising the needs of the future.
Okay, thank you. Darshil, do you have anything you'd like to say?
Yeah, sure, Steve, thank you. I think that's a really good question, because from my perspective, we work a lot on bio-based composites, and I often do highlight even to students that just because you're using bio-based precursors, that does not necessarily mean that your end material is going to be sustainable. And I think with increasing discussions around what sustainability means, and in terms of indicators, we have carbon emissions coming up more frequently nowadays. End-of-life waste has always been there, but I think in terms of sustainability, my perspective would be something that, as Vicky and Dipa have mentioned, hopefully continue to circulate without being detrimental to the environmental or society, and still function valuably to the economy. I think those three pillars, as we commonly mention.
Okay, James, do you want to add anything?
Yeah, I could probably only add what has been said by the last three speakers. Literally, the sustainable materials, in my perspective, will refer to materials which we can probably reuse over and over, perhaps in different forms and shapes, but be able to recirculate and reuse the material without necessarily harming the environment. Whether that is necessarily green composites or is synthetic composites to some extent, we can probably debate that, but I think that's why we had this panel.
Eleni.
I totally agree with the rest of the panelists, so I will probably extend a bit a few points. So I guess things to highlight regarding sustainable composites is the manufacturing process, how basically we can reduce the heat energy input on the system, apart from using natural fibers. And the end-of-life scenarios, how we can increase durability aspects and prolong the design life of the material, and basically take benefit of carbon sequestration effects and minimize waste at the end of life scenarios.
Okay, so perhaps I'm going to follow this up a little bit and ask, and I'm going to go to Darshil for this, because I think you might have an answer to this one. Is how do we quantify that sustainability then? So how do we know that something is sustainable? How do we know that a composite is truly sustainable? What are we going to do to measure that sustainability?
Yeah, so I think there are quite a few ways, usually life cycle assessment techniques, which can assess a range of different environmental or other social impact indicators, which range from global warming potential to ecotoxicity or eutrophication. You can measure these and quantify these to actually work out what energy or other inputs are going into the system, including resources, and then also measure the outputs. at each of the different stages. And then you can form a much more holistic understanding of the overall impact. And what tends to happen usually is, firstly, depending on which product stream you're looking at, so the end application, specific life stages of the product may have significant impact or significantly more impact, and that's where we may want to focus on. So for example, one of the places where carbon fiber composites can really and are already doing a lot of benefit are in the aerospace sector by lightweighting technologies and therefore reducing fuel emissions. And that may be incorporated in something like a life cycle assessment. But end-of-life waste and how the end materials are being, what's happening to them, are they being reused, and possibly thinking about these plastics or reinforced materials as material banks, and if they can be reused rather than using virgin precursors, that would possibly make the system a bit more sustainable than it already is in the aerospace sector, but definitely in many other sectors where we are using these. Commonly, it is embodied energy and carbon emissions that are referred to as environmental impact indicators, but there are quite a range of others that we need to be wary about, particularly end-of-life waste, I think.
Okay, we've got a question here. This is a challenging one. So how do we address the elephant in the room that is global capitalism? Sustainable composites definition is flawed by the fact that the needs of the present are objective and constrained property requirements, whereas the needs of the future are speculative at this point. So does anybody want to take that one? Who would like to grapple that one to start with? Go on, Vicky, you can have a go. Do you want to have a go? Because you work, I mean, you represent industry, right, in terms of the so, you know, industry is on the growth model, and I say this to my students, actually. I show them the growth of composites, you know, there's a growth curve. But it's a growth curve that's directly related to consumption. Okay, so it's consumption of raw materials, it's consumption of sources of energy. Obviously, we can't consume energy, energy just gets converted to another form. But essentially what we're doing is we're fragmenting that energy into various different parts, and that's possibly the problem with composites. But how do we make it much more equitable?
I think it's a really good point. I think it's a really good question, and it does follow on from the previous question, really, which I think is about measurement, taking the measurements carefully, understanding the measurements, and thinking through what those life cycles might be, considering the embodied energy of the materials, and thinking through what the consequences are in the use phase and at end of life. Something that is a fact of the way that we live. We want to travel, we want to use vehicles, we want to go places, and we need to think carefully about how we do that. Of course, there are some extreme options, but we have to consider those three pillars of the environmental, economic, and social aspects of sustainability.
Dipa, do you have anything you want to add to that at all? Sorry to you.
Yeah. No, I think this is exactly what Vicky mentioned. That is absolutely, everyone has that kind of responsibility of thinking in their own way how this can be addressed. But at the same time, I think we need to think parallelly how more, like more natural, greener, eco-friendly materials can be brought in use. And in parallel, actually, we need to think about that as well, apart from, because we cannot suddenly stop using synthetic materials. That's not possible. So they will be there. But in parallel, we have to kind of find out or identify which are the areas where we can actually replace some of these more synthetic materials with little bit of greener ones. And that transition has to be started somewhere. I think we need to put a lot more attention in that area right now.
James, you've got your microphone open.
Oh, right. I think if I were to add there, the other area perhaps we may want to look more into details is the production stage. The way we synthesize most of the materials is quite often is chemical intensive or heat intensive. So the energy consumption within that level, are there ways we could reduce that? Could we perhaps, for instance, use more renewable energy in terms of production stage? Could we probably use chemicals which are not as aggressive as today, but probably more useful to, or more easier to recycle, to be able to reuse that for a different purpose? And if you're to do that, then perhaps you reduce some of the, for instance, the toxicology element of it, perhaps the environmental impact part of it go down a little bit based on the energy. And if I were to add on there, the understanding of what's sustainable and what sustainable means in people's context, perhaps that need to be more defined and probably more probably understood in the context of the materials you use. If you're traveling for a holiday, for instance, or going to London to watch football in Weybridge, so you're kind of using lightweight vehicles. And although those vehicles are made of, they're made of new materials, most or sustainable materials, the way we use them may not necessarily become sustainable. So there is a balance there, but mostly on the material side, there is probably an education piece as well related to how we waste, how we recycle our waste, how can we turn that into good use perhaps, and is a cycle, but probably sometimes viscous cycles. From industrial perspective, I'm not sure whether the easy solution, but there's probably potential for optimizing perhaps.
Anybody want to add anything else at all?
Yes, I do agree with a lot of points. For example, it's up to our personal responsibility to a great extent to change perspective and basically employ more sustainable practices, but also it's up to governmental policies and how incentives can be given to use sustainable materials and basically on specific applications where there is a room and scope at the moment. Because we can aim for a direct target in terms of 5 years and what we can do in the long term, like 20 years from now. And for example, in my sector, there is, in France, for example, there is incentive from the government to use at least 50% of construction materials out of timber regarding public buildings. So there can be some steps and incentives by the government to change a bit the public perception and how we can adopt more sustainable materials in engineering.
Well, you make a good point there, because the petrochemical industry is heavily subsidised, and there are lots of incentives to dig oil out of the ground in order to make from oil. There's not so many incentives to use sustainable materials. There needs to be more. So I think you make a good. So I think the system is wrong. I think it favours a certain type of behaviour, and it's a convenience that we do all what we're doing. But I think that there are ways in which we could change global economies to encourage us to leave the oil in the ground, because that's where it needs to stay. Dipa, you made the point. You said that it's impossible to move away from synthetic materials. Do you think that's true?
I think this cannot be done in one day. That's the point. So we need time to really move away from synthetic materials, because they have some good points as well. Everything is not bad about them, but it is how we are using them, how we are really designing them for the end of life. So that we have a bit of role in the all harm they are causing, So I think it's not a thing which can be really changed in 2 years or 5 years time, but it will take time. But the transition should be a bit, smooth and more balanced, because in society we have to carry on things what we are doing. We certainly cannot stop, doing what we are habituated in doing every day. So I think that's, and also in this respect, I think it's important to educate the young engineers to bring the knowledge and interest on sustainable materials, sustainable manufacturing, and responsible recycling, to the future generation, because in next 10, 15 years time, they will be more, leading, taking it forward. So in the education system, I think we need to focus a lot more on bringing the kind of this type of, information or knowledge or courses to integrate that with the current education system, so that there are more kind of information available to the young budding engineers for future.
Yeah, Darshil, you got your hand up.
Yeah.
You're really keen to say something. Go on.
Yeah, if I can just add to a couple of points that Dipa, Eleni, and James made. I think firstly, education I think is really critical, and combining it with what James was saying about he used the word good use. I think similarly, good design, and design is something Dipa touched on as well. I think we need to be educating engineers, product designers, and the public in general a bit more about what is good design, including design for disassembly and reuse particularly. And I think that's where composite materials need to develop a bit further in terms of cascading utilization, or in terms of design for disassembly, so that it may be reusable in the same or a different application. Alongside that, I think flipping one of the anonymous question on its head, I think it may have been related to, we always speak about these 3 pillars of sustainability in terms of environmental, social, and economic. Is one pillar bigger or supposed to be stronger than one of the others? And at this stage, should they all have equal importance, or should there be a level of ranking or something that needs to take precedence over the other? And is that something that we need to think about? I think alongside educating about composite materials and green materials, maybe a lot more life cycle assessment, understanding how that is carried out and what it means and why we should be doing it, could also, play an instrumental role. And Eleni made some really good points about, putting that in place through policies as well, making it more mainstream and supported through governmental organizations and others.
So I've got a question here from Richard Trask. He gives me a bit of praise at the start, so it's great talking with him. So no problem. I think some of the things have been addressed already. He does make a few pertinent points about how can we educate designers and start the process of change from the start of the component cycle. And there's a really pertinent question here, is LCA our only tool? There's a question for you. So who was singing the praises of LCA? I think it was you, wasn't it, James? I can't remember now, but maybe James would like to take that one on. I don't know.
No, I don't know. I don't think LCA is probably the only assessment. Perhaps you can also include things like social impact as well. Where the green of material sourced, whether green or oily, either of them, they have very huge consequences. So if you associating green composites with food, then the development of that becomes very difficult to pursue further down. So it's not just about cost. It's I would think social impact has a huge part to play on it.
Okay. Anybody else want to answer that question about LCA? I think you've answered.
I guess I could add something regarding sensitivity analysis that is needed for life cycle assessment, especially regarding if you use different libraries with different values. So this can be tricky sometimes in terms of your end result. What is the most favorable option? So in this case, I think it's a good practice to use different libraries and do a sensitivity analysis to inform better your final decisions, because you might find different embodied carbon values from different data libraries, and this is related to what are the assumed boundaries, etc. We have to be careful on how we interpret and basically the final outcomes from the LCAs.
Yeah, so there's a question, and John's come back actually with something. So I think it's really important we look at other things as well. totally agree. I think there are other indicators that we need to address. I also wonder how global LCA is, whether we can really make global decisions. Is it translatable to other countries and economies and the trajectories that are they on? Does anybody want to take that one on? Is it a tool that we can use widely, I guess, in the world?
I can try, but all I'll say is that it's very widely acceptable as a tool to use for assessment of environmental impact. I think quite often the question is about the data being used, and I think Ern is absolutely right that the variety of the data source you have, the more accurate so that data is, perhaps the better it is and the easier it is to defend it. The sensitivity part of it, of that process of quantifying the life cycle assessments, it kind of affiliates also with the performance issue that you get into. So you may have a very good RCA rated material, but not necessarily engineering performing. So there's a correlation there as well, which is probably a diversion from the original interest of having RCA as the dynamic tool for making that decision.
Okay, thank you. That's good. I'm going to move on to John's comment now, and this really is about human behaviour. So perhaps, in spite of what we might do in terms of making or using composites to achieve sustainability, say through lightweighting, humans will demand certain things. So he's saying, well, actually, the new Mini Clubman is about over 100% curb weight increase relative to the 1959 original, and actually fuel consumption is broadly similar. And you could do similar things with aerospace as well, because if you make a plane lighter, you say, well, it reduces the fuel consumption, but actually that it also makes the range of the plane longer. So actually people are able then to fly further, without a stopover, and so actually it just drives other things. So how do we alter human behavior? How do we break that cycle? Do we have to? I mean, if you have an SUV, right? Does everybody in the family always drive in it? Or is it driven by one person to the supermarket? Are we being as clever as we might be with some of the products that we're producing? Darshil, I'm going to throw this one at you.
Thanks, Steve. I think, yeah, that's a really tough question because it relates to human behavior, and that is hard to predict, and often, especially in democratic nations, that can be a bit challenging also to how to change that, although that is possible. I think for starters, I do really think that if as engineers we think technology will solve all our environmental problems, then I think we're in a bit of a muddy place. It is actually going to be changes in human behavior and understanding of the limits of consumption, particularly, that are going to solve it. We may be able to make things lower carbon, but the problem is the rate of consumption and how much material we are using or energy we are using in producing a product in the first place. And that's something we talk about even in the built environment sector, which is one of the biggest polluters or has the largest carbon footprint. Even if we were to make most buildings out of timber, that doesn't mean we want more and more buildings. We still need to be using and retrofitting existing buildings or demolishing less buildings. And therefore, similarly with other things, we need to be thinking about how we can inform human consumption and behavior to try and use less. And alongside that, making some of the materials better, decarbonizing our electricity grid and things of that sort. But I'm sure others will have lots of points, Vicky particularly, because she has done a lot in the circular economy sector.
And I think in automotive, there's a massive disruptive change happening right now, that's been brought about by regulation, thinking about fuel efficiency. And of course, this is where the issues around measurement techniques and thinking very carefully about raw materials and embodied energy impact on the differences between, you know, vehicles with the internal combustion engine and vehicles with batteries. But this change is happening right now, and it's because of the climate change and the issues around CO2 emissions. So those changes do occur, but it is true, as is highlighted in the question, about you know, the changes in technology, more safety aspects with vehicles, and all of those things combine to increase the curb weight. So yes, it's a challenge.
Yep, thank you very much for those answers. Well, we're going to get down to some real technical stuff now. Rishabh is asking, I think I pronounced your name correctly, forgive me if I haven't. I'm interested to know about 100% biodegradable matrices. We already have plant fibres, but we have impregnation problems with thermoplastic matrices. How can we tackle this? Okay, how can we tackle biodegradable matrices? Dipa, you sent me an email about biodegradable versus recyclable versus. Perhaps you'd like to take this one, because you've obviously got a clear view about it.
Yeah, I think, to kind of start this point regarding biodegradable or renewable material-based resins. So we might have a thermosetting as well as thermoplastic. So I think the question is more on thermoplastic, biodegradable thermoplastic matrix. So just let me go back to the question for impregnation problem. Yes. So with thermoplastic matrix, of course, the impregnation is quite difficult with the viscosity and other problems, other stuff. So one way might be commingling. I don't remember. I have seen a lot of pre-preg materials with plant fibers and thermoplastic fibers, which is quite common with polypropylene or even PET. But I haven't seen that much with normal other biodegradable materials like PLA, but I'm not sure. There might be something jute PLA might be there, but commingling might be one way where we can actually tackle the high viscosity of the thermoplastic matrix, but still we can impregnate the plant fibers with that. So that can be definitely one. And apart from that, short fibers are quite straightforward to use in extrusion. But in case of structural composite, when we want to keep the continuous plant fiber, the impregnation becomes much more difficult because of the high viscosity. Immediately, I can think of commingling technique where we can make thermoplastic composites. But at the same time, thermoplastic tapes are now being manufactured in different ways where continuous fibers are impregnated with biodegradable materials. So there are different techniques, hot melt or powder slurry type of technique, but those are getting a little bit, I think, more popular nowadays.
Yeah, okay, that's great. It's just been thankful answer, so that's super. I think we'll move on to the next question, which also involves an issue with natural fibres and matrices. The differential thermal expansion between natural fibres and the matrix is more than carbon fibre matrix composites, making it more prone to residual stress generation. So how reliable the structural integrity of natural composites? How reliable is the structural integrity of natural fibre composites compared to their synthetic counterparts? Questions. Does anyone want to take this? Eleni, do you want to take this? Or James, I don't mind. Maybe want to throw their hat in and say something on this? Do you agree with the statement? Yeah, go on, James.
Yeah, I would think the biggest problem with the structural integrity associated with the fibers is probably how we prepare the fibers themselves, and probably how opportunities we probably take or miss around, for instance, compactorization, so that we can increase the surface qualities of the fiber. And the level of protection, if I look back on how we prepare the fiber, for instance, in natural fibers, for instance, you weigh out the fibers and then you wash out with different acids and so on, and then later on you recoating back on. And that process end up degrading the fibers, particularly natural fibers, in the long run. So the easier way to do it is probably finding a standard way of, in my opinion, probably using compactorizers, which can then be tailored to feature a certain polymer group. And through that process, then you probably have an interface which is probably tailored for a certain function, and therefore the degradation within that particular property become much more reduced compared to otherwise what it would be if that process was not there. The coating processes work well in some cases, but the coating itself need to be properly well aligned to what the function is. So if the fiber is exposed, for instance, in tension, and the coating does not allow enough tension, the coating then become part of the problem rather than the solution in that case. So that would be my initial think around that. There's probably also physical boards to think about as well, which again can be optimized. It could be partnered with feeders, could be partnered with compactorizers or surface layers on the fibers as well. There's quite a few options we can explore there, but literally it's the property based and it's performance based on a specific application, in my opinion.
Yeah, I mean, I guess the only issue with surface modification is you add cost to the production.
It is costly.
Yeah, so that's something we need to consider. I mean, there's something other than just the thermal stability, is also moisture sensitivity as well.
Mm-hmm.
The natural fibers and the swelling of natural fibers in moisture.
I mean, it's worth thinking most of the fibers will also be hollow. So particularly natural fibers will be hollow, so they have other advantages. We could probably utilize that hollow fibers, but it could be also a drawback depending on what you're looking for. For instance, if you're looking for damping, that works quite well. But if you end up you have ingression through that process by water or moisture, then you've got a lot of problems.
Yeah, rotting. Your composite panels start smelling, right? Yeah. So we've got a comment here from Marco about the system boundary of LCA, and I guess it goes back. I mean, he talks about the electricity used to charge them, and it's something that I wanted to pick up with you. I mean, this sustainable composite materials is all very well and good, but I mean, I'll take the example of this. I'm terrible. Look, I'm drinking bottled water, but this bottled water, right? It's Evian, okay, and if you do, the LCA has been doing this, by the way. The LCA is better for this bottled water than it is for, say, Buxton water, which I could buy, which is produced in the UK, simply because the plastic and the processing of the plastic uses renewable energy to produce it. It uses nuclear energy. Okay, so when you input that into the equation for the LCA, this comes out better in terms of its environmental impact. So, how are we going to get sustainable composites unless we decarbonize energy? So, is that a priority, do you think?
Certainly one of the priorities, isn't it?
Mm-hmm.
And I think when it comes to LCA, and maybe other panel members know better than I do, but being really transparent about what the system boundary is, thinking very carefully about what the assumptions are, and making certain that that's built into the understanding of the assessment itself. And what Darshil said earlier about being able to choose the impact categories and being certain that nothing is masked or hidden by the selection of the most appropriate impact category. You just got to be transparent about the assessment.
Yeah, completely open. Yeah, I agree. Let's move on then. Here's a question from Gary Scott. Are there any biodegradable matrices that are FST compliant? I've just lost the question because it's something with an answer. Compliant for rail and interior uses. Does anybody know anything about this?
Well, I think furfural resin, I think PFF polyfurfural resin. I think that has a good FST property, but it's a thermoset. It's just from renewable resource. That's the only thing.
Yeah, so furfural, yeah, derived from sugars, right?
Yeah.
And aware of any others?
But not biodegradable, Dipa, is that right?
Yeah, not biodegradable, but just from renewable resource. Yeah.
Yeah, but biodegradable resins, I'm not aware of.
Oh, biodegradable. Okay.
Yeah.
I know silk usually has good fire properties as a fiber, but if you have an all silk composite, I'm not sure what its fire properties are. Because I know, for example, for curtains and for interiors decorations, you do not need fire testing of silk fabrics for that reason. So I don't know what the testing on all silk composites has been, because you can solubilize silk and produce a matrix out of it as well.
Smoke generation is the big issue, right?
Yeah.
It's the smoke generation that's a major problem. And the dripping as well. So you get dripping, the fire spreads.
I do think the realm of biodegradable composites is interesting, although it's not preferable. We, again, because of the thinking behind leakage of composite materials into the environment, what happens at their end of life if we do not have recycled strategies, and particularly if some of these materials are being landfilled or being exported for dealing with the end-of-life waste, then thinking of both circular but possibly linear bioeconomy streams could be worthwhile, in terms of at least the waste is manageable in a less environmentally benign way.
I'm not a big fan of biodegradable simply because it gives us the excuse to throw away.
Yeah.
Okay? So we're disposing of these things, and actually there are some. I mean, my material is cellulose, as you all know, but actually, if you put cellulose in a landfill where there's no moisture and there's no air, it doesn't biodegrade.
No. Yeah.
Although those bags that you can buy say biodegradable in them, they wouldn't degrade in a landfill because they're just compacted down in a zero moisture, zero air environment. So.
Yeah, I think we need a clear kind of understanding where we need actually biodegradability and where we need recyclability. Because if it's a packaging kind of thing, use and throw very short term, then definitely biodegradability might be something we think of. But if it lasts for a few years, then we have to think, really, we want to throw it or we want to recycle it. So I think that clarity is needed.
But there's a huge amount of embodied energy in this. Right?
Yeah.
And, just allow, I mean, we could use that, right?
Yeah, absolutely. Absolutely.
Okay, Dominic's asked a question. He says, completely respects the earlier question of what's sustainable composite, and I'm probably biased, but surely the requirements stroke usage of biodegradable thermoplastic composites will only form a small part of the future supply chain. They are expensive, require higher energy processing, and often lesser performance. As most composite materials designed for high performance and long life, surely the focus should be further development of bio-based thermosets, natural fiber composites that provide performance and life, yet have a much lower carbon footprint. What do people think about that?
I think the best, yes, I think that's definitely a good way to go forward. We have renewable resource-based bioresins, thermosets, but if we can use a recyclable hardener, then it solves everything. It will be bio-based thermoset, but recyclable. So that might be an interesting way to go forward at some point.
I mean, go on, sorry, Vicky.
I was just going to say there's a transition, as was discussed earlier. There's a transition between where we are now and where we need to be in the future.
Yes.
Okay.
I think for thermoset resins, the curing, the hardener, that needs a lot of attention, I think, as we are already seeing now recyclable epoxies are there in market. So if this similar technology can be applied for bio-based thermosetting resins, I think then that can have a real good, have some good solution for this problem.
Yeah, I mean,
and I guess,
go on, Eleni.
And I guess also hybrid structural forms could be of interest, like combining synthetic with bio-based materials, and basically take advantage, exploit the mechanical properties of each one. considering that I guess the end of life scenarios can be more complicated. But now, I mean, there is a lot of research and a lot of applications regarding even reuse and recycling of synthetic materials. But yes, I guess another aspect would be basically hybrid materials.
Yeah, okay, hybrid materials. I mean, yeah, making a composite that lasts a long time, so 30, 40 years, and entrapping that carbon into that application, that's a sustainable thing to do, surely. You know? I think it's the release of that carbon into unusable forms, right? It's
I think, yeah, I definitely agree with that. I think, for example, with the built environment sector, when we consider timber as a building material, rather than using virgin wood to make wood plastic composite, it makes a lot of sense to have deconstructed timber that is not suitable for reuse in a building or not suitable for making chipboard, and then using that and converting that into fibers for wood plastic composites. And I think it just needs a better rethink around the cascading utilization of our bioresources as well, because again, bioresources are slightly limited. They are reliant on land and dependent on where you may be geologically located as well, geographically located as well. And in that sense, whether it is a sisal fiber or if it is a date palm waste fiber or if it is wood fiber, I think there are lots of different resource streams that you could be using, but using them effectively so that you're releasing pressures and long lifespan application sectors, and then reusing those material banks for less either structural or only aesthetic applications.
Yeah, this is going to have to be the last question, right? Okay, so this is from Tim Young. He says, it's appreciating there is a balance between the race to net zero and unintended consequences are, and the unintended consequences are. Do the panel have any predictions on future materials that might deliver truly sustainable materials? So I want a material that you think is going to disrupt. So very quickly, James.
I've not thought about that, but I think I would like to think PHB as a biosource material, but probably with more tailored applications, particularly sourcing it from waste.
Yeah, PHB, the Americans are upscaling the production of PHB at the moment, hugely. Darshil.
I would just go with timber, I think, and wood-based composites, yes.
Dipa.
I think renewable resource-based bioresins, but with recyclable hardeners for structural applications.
Excellent. Okay. Eleni.
I would go for bamboo because it's fast grown. So
Great material. Vicky.
I would like to see emphasis on carbon fiber production from natural resources.
Brilliant. And Marco says, how about vitrinous? Don't forget the vitrinous. Yeah. Okay. Thank you very much, everyone. It was a great session. And so I think we're going to join the main session now. So thank you, everyone, for your session. And thank you to my panel members for all your great answers. And it's been lovely talking to you this afternoon. Thank you.
Thanks for having us.
Thank you very much.
Thank you.
Thank you. Bye.
Bye-bye.